So we now have been successful in measuring the speed of light, but we want to know what determines it. Okay, so I gave a couple of examples last time, so let me just write those down. So the first example I talked about was the speed of a bullet. Okay, so suppose I've got a gun. Gun looks something like this. There's a gun, okay? Good enough. And then this gun fires bullets, and these bullets have a certain speed, right? So let's suppose that this gun fires bullets at 100 meters per second. Okay? Now, if I were to do an experiment where I run with the gun, or drive a car with the gun, so here's me running. What do I look like when I'm running? Something like this. Okay, so I'm running and I'm holding the gun. Here's the gun. Okay, and again I fire the bullet. So let's suppose in this experiment I'm running at 10 meters per second, which is pretty fast. It's about as fast as Olympic sprinters run, but anyway. So I'm running at 10 meters per second. Then if I fire the bullet will have a speed of 110 meters per second, right? Relative to a stationary observer. So what this shows is that the speed of the bullet is determined relative to the gun, right? If the gun is stationary, the bullet has a speed of 100 meters per second. If the gun is moving with 10 meters per second, then the bullet has a speed of 110 meters per second. Okay? So in this example, can I write down here? I think I can. If I write here, can you see it? Not quite. Okay. Let me write. Okay. Because of this, yeah? Okay. Let me write it up here then. Okay. So in this example, the speed of the bullet is determined relative to the gun. Okay. So the speed of the bullet is relative to the gun. Right? If I change the speed of the gun, then that changes the speed of the bullet fired from the gun. Okay? And the general term for the gun in this example is the source. Okay? So the source of whatever I am emitting. So the gun is the source of the bullets. So that's one way in which a general speed can be determined. The speed of an object can be determined by the source of that object. In this case, the bullet and the gun. Okay, but that's not true of everything. So a second example is the speed of sound. So again, I briefly mentioned this last time. Okay, so let me draw some equivalent pictures. So here's me. Okay, got an ear, I suppose. Some hair. There's me. Okay, so I shout something. Hello. Okay, and this sound comes out of my mouth and reaches you with a certain speed. Okay, which is known as the speed of sound. Speed of sound well, in the air, that's about 330 meters per second, I think. So in 1 second, the sound travels about 330 meters. I think. Okay. So again, we can do the same kind of experiment. I run or I drive a car and I shout and see, does that affect the speed of the sound? Okay. So, okay, I'm going to draw it up here. So I do the same kind of experiment. My drawing skills are not very good, you may have realized. Okay, here's me running. That, okay. And again, I shout, hello. And again, the sound comes out. Now, this example is different, right? In this example, even if I run at a speed of 10 meters per second, the speed of sound is not changed. right? The speed of the sound coming out of my mouth is not affected by my speed. Okay? So the speed of sound is not determined by the speed of the source. It's different from the case of bullets, right? In this case, what's the speed of sound determined by? The air, right? So the speed of sound is determined by the air. In particular, the frame in which the air is stationary. Okay? So the air in this room is stationary, so therefore sound travels with an equal speed in all directions. Okay. So I used a couple of terms here which have a technical meaning, so let me just define them. The rest frame of the air means the frame, the observer velocity, for which the air is stationary. Okay? So the rest frame of the air in this room is just standing still. Right? It's not moving. Okay? Whereas if there was a wind, if we go outside and it's a windy day and there's a wind of 20 meters per second or something that way, then the rest frame of the air is 20 meters per second in this direction. Right? So rest frame just means the frame, the reference, in which the air is stationary, not moving. Okay. Also, we have a more general term than this. Actually, sound doesn't only travel in air, right? Sound also travels through water. It also travels through solids. Okay? It can travel through any kind of material. So the general term for this material through which sound travels is known as the medium. Okay? So in this example, the medium of the sound is the air. But the medium of sound could also be water or a solid object, and so on. Okay. Right, so what I want to do now then is ask the same kind of question about light. Okay, how does light behave? So if you look at these two examples, the major difference is that the bullet is a particle. Right? It's a kind of point object. Not definitely, okay. Whereas sound is a disturbance in a medium, right? What is sound? Sound is oscillations of pressure in the air. Right? It's a wave moving in the air. Okay. So we can crudely divide these two cases as this is the behavior of particles, speed is determined by the source, and this is the behavior of wave, the speed is determined by the medium. Okay. So we can ask them, what about light? Now this question took a long time to be answered. Okay? As soon as the speed of light was known, people were thinking about this, right? But experimentally, it's a very, very difficult thing to test. And what we're going to talk about today is how was it tested. Okay? In the case of a gun, because the speed is about 100 meters per second, it's not too difficult to do that test. Okay? Because you just measure the time it takes for the bullet to move from here, say, over there. Okay? And you just measure the time. Speed is distance divided by time. Okay? But for light, the speed of light is 300 million meters per second, give or take. Okay? And this enormous speed means it's very difficult to do this experiment, right? Because suppose in the first example, if I run with a torch and see, does it change the light speed from this to this, okay? That difference is virtually impossible to measure, right? Especially with the technology that existed 300 years ago. Okay. So therefore, there was a lot of time where theorists were trying to answer this question, but without any experimental evidence. So there was therefore a lot of kind of discussion. A lot of different theories were made about this. Okay. So I'm just going to describe what the main theory was. So in the 1700s, 1800s, a lot of experiments were done on light. Okay? And the results of most of these experiments showed that light could be treated as a wave. Okay? Light has wave-like properties. You can do refraction experiments, diffraction experiments, and so on. Okay. So therefore, the most natural thing to think is that if light is a wave, then it should behave something like sound, which is also a wave. In other words, there should be some medium of light, so some medium through which the light moves, okay? And the speed of this medium determines the speed of the light. So this was the most popular theory at the time. The only problem is, with sound, we can actually detect the air, right? It's quite easy to, you can feel the air move, right? But with light, we can see the light from distant stars and galaxies. And as far as we can tell, there is nothing very much in between us. Okay? So it seems like the light is traveling through empty space. It doesn't need air. It doesn't need any kind of material to travel through. Okay? So therefore, scientists invented something. Okay? So scientists at the time assumed that light was a wave. Okay, and there was some experimental evidence for that, which we're going to talk about later on in this course when we talk about quantum mechanics. Okay, so they assumed it was a wave in a medium called the ether. Okay. So we can't detect this, so they just thought of a name. Okay, they literally invented it. Okay? Light seems to behave like a wave, therefore it should have some medium in which it travels. Let's call it the ether. Right? It's just that simple. Okay. So this is called the ether. Some people spell it without the A, by the way. So you may see just E-T-H-E-R or A-E-T-H-E-R. I'm going to use this one. Okay. Okay. So they assumed that there was this ether throughout all of space. And the speed of light was determined by the speed of the ether. So that was the hypothesis, the most popular hypothesis of the time. But as I said, because the speed of light is so fast, it took a long time for this hypothesis to be tested. Okay, like 150, 200 years until they could actually test this hypothesis. Right, so I'm going to tell you about some of the tests of this hypothesis, but before we do that, I just need to do a little bit of calculation so that we can so that I can quantitatively define how these experiments work.